Evaluate the limit as x approaches 0 of sine of 4x over sine of 6x. All right. Now we're getting to something that is a little bit more interesting, a little bit more complicated. We have two different signs of things, and we don't have an x underneath them, or a 4x or a 6x. So we have to be a little bit more thoughtful in what we're going to do here. So I'm going to rewrite our limit down here. So we've got the limit of sine of 4x over sine of 6x. And if we're going to use sine of x over x, this tool that we've been using, what we're going to need to do is we're going to need somehow this sine of 4x to be over 4x, and we're going to need this sine of 6x to be over 6x. So what I want to do is I want to take the numerator and denominator of this fraction, and I want to divide both of them by x. We're going to divide the top and bottom of this fraction by x. So that's going to give us the limit of sine of 4x over x all over sine of 6x over x. All right, we can divide the top and bottom of a fraction by the same quantity. We're not allowed to divide by 0, but here's the interesting thing. We're looking at the limit as x approaches 0. So we're looking at values where x is near 0, but not equal to 0. At all of the points that we're actually looking at, as x is getting closer and closer to 0, x is not actually equal to 0. So we're able to do this. So now we have rewritten things so that they look a little bit closer to what we need. But remember, we need this to be sine of 4x over 4x, and we need this to be sine of 6x over 6x. So I want to just look at the smaller fractions separately. Let's ignore the fact that they're a part of a bigger fraction. If we look at sine of 4x over x, the way that we can get this into the right form is by multiplying the top and bottom by 4. We're multiplying the numerator by a creative version of 1. And then we can do something similar in the denominator. I bet you can already see. We want to multiply this by 6 over 6. Now what that does for us, we've got the limit as x approaches 0, is it allows us to rearrange things so that we can put things in the form of sine of u over u. So let's do some rearranging. We've got sine of 4x, which we want over 4x. So I'm going to take this 4 and move it into that denominator. And then that's just going to be times 4 over 1 on the outside, which is just 4. And then we're going to do something very similar in the denominator. We're going to write this as sine of 6x over 6x. We're going to have that be times 6 because we're taking this 6 in the little denominator and moving it over there. All right. And so then at this point, we know that the limit of a quotient is the quotient of the limits, so we can split this up into two limits. And remember that the limit of something times a constant is just the constant times the limit, so we can pull those constants out front. And so what this is going to give us is, let's separate this into two limits and pull the constant multipliers out front. This is going to be 4 times the limit as x approaches 0 of sine of 4x over 4x all over 6 times the limit as x approaches 0 of sine of 6x over 6x. Now, we're actually going to have to make two substitutions here. We can't just let u be 4x, because here then we can't let this be sine of u. So we're going to look at the numerator and denominator completely separately. And so in the numerator, we're going to let u be 4x, And in the denominator, we're going to let v be 6x. So we're going to set up different substitutions for the numerator and denominator. We're going to evaluate them completely separately. Also, 4/6 reduces to 2/3. I think we're all comfortable with just making that reduction since those are out front. All right, if we make these substitutions, then the numerator becomes the limit as u approaches 0 of sine u over u. We know that as x is approaching 0, 4 times x is also going to approach 0, which means u approaches 0. And we're going to have similar logic in the denominator. V is also going to approach 0, and this is going to be sine v over v. And we know that both of these limits are equal to 1, so this is just going to be 2 times 1 over 3 times 1, which equals 2/3. Once you get to the point where you've done enough of these substitutions and you feel comfortable with it, you can skip the step of writing out all of these substitutions explicitly, and you can do it in your head. At least that's what I feel. Some instructors might feel differently, but you do need to make sure that whatever substitution you're making for your u, or in this case v, that whatever x was approaching 0 also means that u is approaching 0. If we made a substitution, I'm just going to do this off to the side. If we had a situation where we let u equal 4x plus 1, for example, then as x approaches 0, u is actually not going to approach 0. U would approach 1. Because as x approaches 0, 4x approaches 0, so then 4x plus 1 is going to actually approach 1. So you have to be careful that you're not making a substitution that sets things up so that u is approaching something other than 0. So we've got to be careful here. This substitution wouldn't work. But so long as you're making a substitution where the u is also going to 0, and you can see that you're going to end up with the limit as u approaches 0 of sine u over u, then honestly, I think once you've got enough practice, you can do that last step in your head.